Hi, my name is Stuart Lynch, and this is the fourth video in a 7-part series on building a full weather app using WeatherKit. In this video, I'll start with a redesign of our CitiesList view to display more information on our cities, and then we'll add an hourly forecast for each city. In addition, we'll do some more refactoring of our code to clean it up. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. If you're working along with me, you can continue on from the source code that you completed in that last video. However, if you're just jumping in here and you want to work along, you can download the completed project from that last one. Make sure you download the branch from video 3. I've already started a new branch now for this video, and the completed source code for it will be in this branch. Links to both branches are in the description. Just remember, if you download from the branch, you'll need a developer account, and you'll have to change your bundle ID to your own, and make sure that WeatherKit is enabled on both the Capabilities and App Services tab for the app identifier for My Weather. Now, before we move on to getting other types of forecasts, I want to improve the look of my CitiesList view. I'm going to be replacing the text view in the list with a more detailed view that'll present a lot of the same information for each city that we display in the current forecast view right here in the list. So inside the CitiesList view folder, create a new SwiftUI view and call it City Row View. Import WeatherKit. And since this view might display the weather for the current user's location or any one of the other cities, we'll need a number of different properties here. First, I'll need access to the Weather Manager's shared singleton. For the current location, I'll need access to the environment's Location Manager. We'll be fetching the current weather for each row, so an instance of that, which will be updated by the Weather Manager, is also required, and it's optional initially. And we can display a progress view if we are loading the asynchronous weather call, so a Boolean property for that. And we can display the time, so long as we know the time zone, so a state property for that which we can update. Now each row will be formed by passing in the city from our list, so a let here for that city is required. You can stop the preview from complaining and help us with the design by passing in the city.mockCurrent version of the current location and add the location manager to the preview environment. And then replace the body with a VStack. So return to the forecast view and copy the entire fetch weather function from there. In this view, we'll be doing more with this later, so don't worry for now that I'm duplicating the code. This will just make it easier to follow. So return to City Row View and paste that outside of the body. Then attach to the VStack a task that watches for changes in the city property, which will happen every time the view is called, and await the result of that function, passing in the city. Inside the VStack then, you can start with an if clause to see if loading is true, and if so, present a progress view for that row. Else, you can use an if-let to unwrap the current weather. Once it's unwrapped, we can use its properties. So inside here, we'll create a VStack with an alignment of leading. And then start with an HStack. Inside here, create another VStack with alignment leading. And then in the VStack, we'll present a text view using the city name. I'll set the font to title, scale to fill with a minimum scale factor of 0.5, and then set a line limit of 1. And then I'm going to create another text view that displays the current weather date for local time for that time zone, and set it to bold. Outside of the VStack, in the HStack, create a spacer. And then to display the temperature, we can get the proper format by setting a temporary constant called temp. That is the Weather Manager's temperature formatter string from the current weather.temperature. Then use this to present a text view with the temperature. Let's set the font to a system size of 60, where the weight is thin, and a rounded design. And let's apply a fixed size of horizontal and vertical, both being true. Outside of the HStack, create another text view displaying the current weather's condition.description. And then to the VStack, add some padding and set the max width to infinity. Then you can apply a background to the entire VStack. So we'll use an if-let to unwrap the current weather condition into a condition property. And then we can use a background view passing in that condition. So we'll return to CitiesList view and replace each text view in the list with a call to the city row view by passing in that city. So first the current city for our current selection, and then within the loop itself. And then the preview is going to crash, so we'll need to inject Location Manager into the environment here to get it back. Now I'm going to surround both of those views of our cities rows with a group so that I can apply some modifiers to both. So I can then apply a clip shape of a rounded rectangle with a corner radius of 10. And then I'm going to set the list row insets to a top of 0, a leading of 20, a bottom of 5, and a trailing of 20. Now let's start adding different types of weather forecasts that are available to us. And the first one that we're going to do today is the hourly forecast. And this is going to provide us with the weather forecast for 25 hours, the current hour plus the next 24. Well, I want to display this in a horizontal scroll view. So first, though, we'll need to get that information. Back in Weather Manager, where we have a function for current weather, I want to duplicate that function, but I'm going to call it hourly weather and have it return not an optional current weather, but rather a forecast type, which is hour weather, and make it optional. And then all I have to do is change the constant to be an hourly forecast for the forecast and change including from current to hourly. And then I'll return the hourly weather instead of the current weather. So let's drill down on our weather and see what we can get. Like current weather, there are a number of different properties. Let's pick some to use that might be useful for our user base. Well, there's the temperature for sure. Now I won't display the condition. Rather, I'm just going to display the symbol if it's available to us. The date will be useful so that we can get the hour for when we're seeing this forecast for. As for the precipitation, I think the precipitation chance would be a good thing to display as a percentage. And here's the symbol, so we're good to go. So back in forecast view, create another state property for hourly forecast. But I'm going to create it below the current weather property and it's an optional forecast of our weather type. In the fetchWeather function, we can make an asynchronous call to the Weather Manager's HourlyForecast function, passing in the city.clLocation property to update the hourly forecast. Now, since this is going to be giving us an array of 25-hour weather objects, and each one having a temperature, we should be able to calculate the high and low values. At the top of the view, create two computed properties. For the first, we will call it high temperature, and it will be an optional string. In the body, we can use a map function on the array of hourly forecast objects and extract the temperature to get that max value. This will be optional, so I'll use an if-let to unwrap it to a property that I'll call high. And then we can return the Weather Manager's temperature formatter string from that high value, else we'll return nil. Well, I can copy that computed property and change it to low temperature, and then extract the low as the map with the minimum value and return the formatted low. Just as an aside here, I record the video of all my tutorials first and then go back later and record the audio, and then add it to the recording and edit the videos and audio to match. I didn't catch this mistake here until I had finished recording all of the videos, so that mistake will persist throughout the rest of the series. Now, I've corrected the source code in my Git repository, however. I apologize for this. I guess I'm just not perfect after all. I'll make note of it in each of the subsequent videos so I don't get all those comments popping up in my YouTube feed about my mistake. Anyway, back to the view. In the view then, just below where you display the current weather temperature, you can unwrap the optional with an if-let and display the string h:, followed by using string interpolation to display that high temperature. And then follow that with a couple of spaces and a corresponding capital L:, and the low temperature. And you can make it bold. Now, this is helpful, but I don't like the fact that the temperature is displaying the unit. Unfortunately, I think there is a bug in the formatter. If I try to add a formatter unit option of temperature without unit to my weather formatter, it'll always display the temperature in Celsius. So I'm going to leave it as is. There could be another workaround that I could do with some calculations, but this isn't that bad. Now, forecast view is going to get pretty cluttered, so I want to factor out this entire current weather content into its own view. I think I've placed this spacer and attribution view in the wrong place, so let me first move it down outside of this if clause. I can cut out the entire inside of this if clause, and I'm going to create a new SwiftUI view inside of the forecast views group, and I'm going to call it current weather view. And then I'm going to replace the content of the body with that cut content. I'm not going to bother with a preview here as it'll just get too complicated. We know our design is good from what we've seen before we cut it out, so either delete or comment out your preview. But make sure you import WeatherKit. Well, we'll need an instance of the Weather Manager's shared singleton. And we're missing some properties that we'll need to pass in from the forecast view. So let's create them as let constants. We'll need a current weather, which is a current weather object type. We'll need an high temperature, which is an optional string. We'll need a low temperature, another optional string. And we'll need a time zone, which is a time zone type. Return now to forecast view, where you cut out that view and replace it with an instance of the current weather view and pass in those corresponding properties. We'll be doing the same thing for our hourly forecast view, but first let's design it in the forecast view where we can see the results of our design. Well, after the if-let current weather clause, add a divider to separate it. Then create another iflet to unwrap and use the hourly forecast to create this view. Well, we'll start with two text views. First, one that says hourly forecast, and set the font to title. Remember, we're in a VStack right now. So for the second, use the string next 25 hours and set the font to caption. Remember, I said I want this to be presented in a horizontal scroll view, so create a scroll view for horizontal. And then let's use content margins for all edges set to 15 for the scroll content. Inside the scroll view, we can create an H-stack with a spacing of 15, and then apply a font of a system size of 13 for all the text that we will be putting in there, and set the frame to a height of 100. So now in that H-stack, we're going to create a for each loop to step through each of the hourly forecast items using the date as the identifier to give us the hour, which was an hour forecast type. So now that we've got that hour, I can create a VStack with a spacing 0. Inside the VStack, I'll create another text view displaying the hour.date using our local time for the time zone. And then I'm going to add a divider and then a spacer. I'll create an image using the system name for the hour's symbol name. And then because I want this in color, if it exists, I'll set the rendering mode to original. And I'll set the symbol variant to fill. And that'll give us the multicolored version for those that have it. And I'll set a font to a system size of 22. And then I'll add a little bottom padding of about 3. And then I'm going to create an if clause to check to see if our hour.precipitation chance is greater than 0. Well, if it is, we'll create a text view to use string interpolation to display that double. And I want to show that as a percent, so one way I can do that is to multiply it by 100. Then surround that calculation with brackets, and then apply a formatted of dot number with the precision being a fraction length of 0. So no decimals, and then add a percent symbol. And I'm going to set the foreground style of this to cyan or cyan, however you say that, and make it bold. Then in the VStack, I'll push the content up with a spacer. Next, I'll display a text view using the Weather Manager's temperature formatter string from the hour temperature. Well, currently my current location in the preview is displaying Cupertino, and it doesn't look like there's going to be any precipitation here over the next 25 hours. So let me go and check one of our other sites. I can see that Paris is mostly cloudy, so perhaps they're expecting rain. Indeed they are. Perfect. Well, now that we see that it's working, let's refactor this to its own view like we did for current weather. So let's cut out the contents of this iflet hourly forecast view, and we'll do the same thing that we did for our current weather. In the forecast views folder, we'll create a new SwiftUI file and call it hourly forecast view. As before, I'm going to remove the preview and replace the content of the body with that cut code. I'm going to have to import WeatherKit, and I'm going to need 3 properties. First, an instance of the Weather Manager's shared singleton, call that Weather Manager. And then from our forecast view, we'll be passing in an hourly forecast, which is a forecast of type our weather. And we'll also pass in the time zone, which is a time zone type. Then I return to forecast view, where we cut out that code and present the hourly forecast view, passing in the hourly forecast and time zone. Well, there's one more thing I should fix though. Depending on the background, this horizontal scroll view might not show up very well. So I'm going to go back to the hourly forecast view once more, and I'm going to add a background. And that background is going to be a rounded rectangle with a corner radius of 20. And I'm going to apply a fill that is a secondary color with an opacity of 0.2. Well, that's a wrap for this video. In the next video, we'll add our own version of a 10-day forecast to our view. So I hope you're enjoying this series, and if you enjoyed this video, please give it a thumbs up and leave me a comment below. And be sure to subscribe to my channel and enable notifications so that you'll be notified when new videos drop. I appreciate you taking the time to watch the video. Hope to see you in future ones.